I hope all of you can hear me.
Yes, sir.
Right. So let me start the session. So today we are going to look at authentication. Again, authentication not in the general uh, perspective, but we are going to look at how authentication is important in the context of databases and how we can configure authentication in different ways like that, right? So authentication is the act of proving an assertion such as the identity of computer system user. So we said it in the last time as well, authentication is really important in any security environment. So in authentication, what we do is we are going to prove uh, our identity, or there is a party that wants to know uh, our identity and verify identity. So it is basically what authentication is about. Uh, in contrast with identification, the act of indicating a person or thing's identity, authentication is a process of verifying that ID. So identification and authentication is not the same. There is a slight difference. For identification, we have to show who are we. But in authentication, what we do is we are trying to verify, are you who you say you are? So that's simply what we are trying to do with authentication. Is if someone is trying to authenticate itself, so in the verification side, what we try to do is we ask the question from the authenticator, uh, are you who you say you are, right? So that's the question. So there is a verification. It's not the identification. So we said that in identification, uh, we just ask the question, who are you? So the party who is being identified should present identity related material. So in authentication, the party who wants to authenticate itself, so we are asking the question, are you who you say you are, right? So that's the difference. So there is a difference between authentication and identification. So authentication is important uh, because we need to differentiate users uh, based on their identity, right? So in any uh, environment that we are working on security, what we can do is we can only manage the risks that we have, right? So managing the risk is what we are basically doing with security. For security or managing the risk, what we can do is we can work on authorization, right? So authorization is controlling the access to different resources based on a particular policy, right? So then to do that, we need to know the person, the individual, who the particular person is. So that is basically we are going to authorize based on the identity. And in order to make that identification, first we need to work on authentication, which is the verification of the identity. So again, authentication is verification of identity. A user is assigned an identity to recognize uniquely. So what happens with the authentication is once authenticated, a user is assigned an identity. So we recognize this identity throughout this session. To verify the identity, a user needs to hold something that cannot be produced by another. So in order to verify this identity, user must produce something that cannot be presented by someone else, right? So that is the basic premise here. So in authentication, uh, we believe that this authentication fall into three main categories. So we call it factors. So you may have heard that multi-factor authentication. So what factors mean in this place is the categories or the levels that we are going to verify. So the first factor is knowledge factor. So knowledge factor. Next is ownership factor. And the third one is inherence factor. So knowledge factor is something the user knows. So it is about the knowledge. So the user who is being verified, its identity. So the user will present something he or she knows. So it should only be known by the user. No one else should know. So as examples, we can say that is passwords or pin-based authentication is basically come under this category, knowledge factor. It's only known by you. Someone else should not know it. The second factor is ownership factor. So ownership factor is something the user possesses. Something the user possesses. In that case, so you may have had experience in authentication with the help of your mobile phone. So in financial transactions, you may have seen or you may have experienced that one-time password comes to your mobile phone where it verifies the possession of the particular number, mobile number. So the possession of mobile phone. So that is checking or that is verifying the ownership factor. So that is the second factor. And mobile phone, ID card, security tokens. So all these come under ownership factor. Third is inherence factors. So that is known as something the user is. So something inherently built into the user, right? Inherently come with the user. Something like a fingerprint, or maybe the retinal pattern, or maybe the DNA sequence, something unique to the user, so no one else can have it, right? So these are the three factors that we identify in authentication. So when we are saying, or when we go with multi-factor authentication, we need to pick authentication under different categories. So one authentication level might come under knowledge factor, which is basically password-based authentication. And then sometimes you may have seen ownership factor is also being verified, like one-time password sent to the mobile phone, or maybe security token is being verified. So it is going with multi-factor authentication. So picking or doing the authentication multiple times under the same category is not considered as multi-factor authentication. For an example, if you verify someone's identity with the password and another password, so that is basically not considered as multi-factor authentication. So it should come under different factors, different categories. So it is always better to verify more than one factor during the authentication. That is a belief, or that is a standard in information security. So also it's always good to go with more than one factor in authentication. So credential is the term that we use to refer the piece of information which is being used during the identity verification. So that is what we call credential. So for an example, we uh, consider the username and password based authentication. So that is basically the credential. So once authenticated, a trust relationship is established between the user and the system that the user is engaging. So password-based authentications, in password-based authentication, shared secret known by only two parties. So those two parties are basically claimant and the verifier. So basically claimant is the user and the verifier is the system that the user is attempting to interact. So in password-based authentication, the secret is usually a string of characters. And nowadays, in order to avoid, in order to nullify uh, brute force attacks, we need to follow certain standards in selecting our passwords. So password strength is basically how strong, or how uh, to what degree it can withstand with such an attack. So you when you attempt to create user profiles or user accounts in the system, you may have seen that you need to pick passwords with certain standards, having uh, alphanumeric characters, capital letters, simple letters, special characters. So it enforce certain standards in order to increase the strength of the password. Another type of authentication medium is token-based authentication. Uh, so there are many types of different token-based authentication, such as connected tokens. So connected tokens are basically physical items that you need to plug into the system. So it provides a token to it inserts the token to the system. And then contactless tokens. So you don't need to plug in, but you need to bring it close as enough to work with. And there are disconnected tokens as well. So this is a well-known token-based authentication mechanism that sometimes you may have seen. Again, this with in Sri Lankan context, some of the banking systems provide this facility to users. So it has a button and a display like here. So once you press the button, it generates a token according to a very specific algorithm. And while you inserting your credentials, you need to insert this token as well. So it verifies not just the username and password or whatever the credential initially that you establish. It will verify this token as well. Then there are biometric authentication. Uh, so there are identity verification using biological attributes of a individual. So you may have heard that fingerprint, face, voice, retinal patterns, and all these things. And sometimes in very specific applications, behavioral biometrics also considered, such as keystroke dynamics, gait recognition, all these different kind of patterns. Contextual authentication is a user will be authenticated not just based on username, password, tokens, but also it will consider the context of a authentication request. So in here, the context means perhaps it might consider your geographical location. So what sort of geographical location that you are coming from? So this is available right now in many popular web applications where if you are if you connect with such applications from a particular geographical location, or maybe let's say you just log into the system from one country and after some time you travel to another country and then you attempt to connect with the same system where it identified as your geographical location is being changed and you will not be allowed to uh, connect with the system in the same way as earlier. Instead, it might ask uh, or it might try to verify your identity using different authentication mechanisms. And it's not just about geographical location. If you try to connect from a different device or different network or application out of usual day time patterns, so these things will also be considered uh, in contextual authentication. So I think all these social media kind of platforms and Google services, these services use this contextual authentication as well. So if you try to change your country, and I mean change means you travel to a different country and attempt to log in, uh, you will be log out first from the existing session, and you will be asked to re-log in from your uh, usual credentials. So usually this will be considered as a secondary factor in multi-factor authentication. So this will not be used as the main uh, authentication mechanism most of the time. There is another popular authentication mechanism called certificate-based authentication, where it is not much popular with the individual or personal users, but when this communication or the authentication needs arise with the systems, right? So when systems are trying to connect with another system, so such scenarios, these authentication mechanisms might be quite useful. So certificate-based authentication is basically authentication mechanisms built on top of public key infrastructure. Uh, I mean, the best example that we can say is state here, uh, we can authenticate a client or user over TLS SSL mechanism. So we know that in TLS or SSL, it establishes a secure connection based on public key infrastructure, where so the client and the server exchanges, some challenges will be tackled, right? So session key will be generated based on certain protocol. So same process can be followed in order to authenticate a client as well. So when a network connection over SSL is initiated in general context, when a network connection over SSL is initiated, what happens is the client and the server perform SSL handshake. So this handshake is basically following several steps in order to verify uh, the identities of the clients and the server. And ultimately, once verified, there is a trust relationship between the client and the server. So that's what happened with SSL. So the same protocol can be followed in order to authenticate any party with the server. Uh, so if we consider the SSL handshake and in its steps, first what happens is the client and the server establish their cipher suite that they are going to work on during this session. So this includes uh, the encryption algorithms they are going to use during this session, and agreeing on the hashing algorithms and all these things. So it's basically agreeing to a particular cipher suite. So that is the first step in this conversation. So then the server sends its certificate to the client. So first server sends its certificate to the client, and the client verifies that server's certificate with the help of certificate uh, authorities and certification hierarchies. So this step verifies the identity of the server, because server sent the certificate and the client can verify. And then what happens is client sends its own certificate to the server. So the server verifies the client's certificate with the help of certificate authorities, or the hierarchy will be followed. So once client and server both verified, um, so it's basically the session, or they are establishing the trust relationship. The client and the server exchange key information using public key cryptography. So based on this information, each generates a session key. So once they are agreed upon this session key, all subsequent communications between the client and the server will be encrypted and decrypted using this session key. So that is how this authentication happens, authentication and the communication happens in the SSL. So in SSL, or basically TLS, in order to communicate securely, first they need to authenticate both parties, or at least the client. So in that case, there is already a mechanism based on security certificate based authentication. So we can adopt the same authentication for our authentication needs. So in that case, one requirement is all parties who want to authenticate themselves need to have a security certificate. So it's not like password-based authentication. You need to have a security certificate, which is provided by a certification authority, a trusted certification authority. So with the help of this security certificate, you will be able to authenticate yourself to anyone. So advantages of certificate-based authentication. The first is we call it the security. The level of security will be much better. So we call it stronger security. Certificates are basically cryptographic keys that provide a higher level of security compared to passwords. So passwords are basically something that is easily compromised, whereas certificates are not such easily uh, retrievable. Certificates are typically issued by a trusted certification authority and are difficult to forge or compromise. They offer strong encryption and digital signatures, so it makes them resistant to eavesdropping, replay attacks, and brute force attacks. Second reason is elimination of password. Certificate-based authentication, we don't need passwords at all, because the authentication happens with the help of certificates, so we don't need passwords at all. So certificates basically are stored securely on a particular way. So its protection is uh, maintained. Another reason is we can authenticate both parties if required with the help of these security certificates or certificate-based authentication. So we can enforce both client and the server authentication. So it's basically server authenticate itself to the client and client authenticate itself to the server. So both parties can be enforced to authenticate. And centralized management certificates can be centrally managed and distributed by a trusted certificate authority. So organizations can enforce uniform security policies and if necessary, uh, it can revoke certificates if the certificates are compromised or lost. So this centralized management simplifies the administration and reduces the overhead associated with password-based authentication. Next is integration with existing infrastructure. So what it means is certificate-based authentication can work with existing infrastructure, such as public key infrastructure and directory services. So it will enable smooth integration with enterprise systems and applications. So organizations can work with existing systems. Compliance requirements, which means some of the cases you need to follow certain regulatory standards and also the best practices defined in your industry. So it might be a mandatory requirement to follow those standards. So this certificate-based authentication might be a must to follow. And apart from this, we can enforce authentication over network, like Active Directory services in Windows, or maybe any other LDAP or like Directory Access Protocol directories, or servers that facilitate Kerberos authentication. It facilitates to authenticate over an untrusted network. So Kerberos is something that provides the facility to authenticate a user over an untrusted network. So Kerberos is basically the default authentication protocol used in Active Directory. As I remember, Active Directory uses Active Directory services uses Kerberos by default as the authentication mechanism, and any other external authentication systems such as cloud-based identity providers or maybe third-party identity access management solutions. So we can integrate such authentication mechanisms, external authentication mechanisms, when we require authentication. Multi-factor authentication. So here authentication is verified via two or more factors. As I said earlier, it should come under different factors, not come under the same factor. So more popular approach is first using knowledge factor like a password, and then second using ownership factor such as having your mobile phone with you or not. Multi-level authentication is a different concept. There can be uh, verifications at different levels during a single attempt at logging into a system. As an example, uh, a database server may verify or uh, authenticate a user at the server level to establish a connection to the server, and at the database level to establish access to the database. Uh, Sometimes third-party applications can also be used with a database environment to further add security to authentication of the user. So such approaches are called multi-level authentication. So you attempt to authenticate at the operating system level, maybe database level, maybe network level. So one common application or one uh, common approach when we are securing a data environment is first we try to fix the operating system of the authentication. The operating system itself will be used to authenticate. So operating system account credentials are used for database authentication. Typically no separate credentials. Um, the same OS credentials, OS authentication credentials will be used. Uh, Most of the time, this type of authentication is used for the database admins where they log into a machine and then connect with the database to configure and define things in the database. So in the Oracle context, so these final statements only applicable for Oracle. So when a connection is attempted from the local database server, the OS username is passed to the Oracle server. So let's try to figure out how Oracle manages this operating system authentication, or how Oracle allows operating system authentication. So that is basically means you are authenticated at the operating system level and no need to um, provide your credentials at the database level, right? So once you log into your operating systems, you will be able to work with your database without having much problem. So Oracle has its own way of uh, implementing this OS authentication. So it has different authentication mechanisms to facilitate different authentication requirements. But for operating system authentication, it has an authentication mode or authentication mechanism called external authentication. So it is basically saying that the user is not authenticated at the database level, it will be authenticated externally. The user account is maintained by Oracle database, but password administration and user authentication is performed by an external service. The OS username is passed to the Oracle server at the time of user attempts to connect. So when the user attempts to connect, operating system username is passed to the Oracle server because user has already logged into the operating system. So that username will be passed to Oracle server when the user attempts to connect, and if the Oracle server recognizes the username that has been passed from the operating system to the Oracle server, and the username is recognized by the server, the connection will be established. Otherwise, connection request will be rejected. So the database server should identify or recognize the username that is sent by operating system. Let's see a very specific scenario that we are trying to configure a user with operating system authentication, or the user enabled with operating system authentication. So if it is in Unix environment, so you can add OS user first. You create a user and the password, right? So now the operating system user is created, and you log into the uh, operating system with that user, and you try to connect the server, right? So now with the previously provided credentials, username and password has been defined here. So if you try to log into the operating system with this credential, will allow, because you just log into the operating system and then you attempt to connect to the database server, and it will not allow you to connect. So even though we say that we are attempting to authenticate at the OS level, database server does not recognize the user, so it rejects. So it says invalid username, password, logon denied. So it may be necessary to set up a few environment variables by exporting it so SQL plus works correctly. Um, so in Windows environment, if you follow the same, adding a new user and log into the operating system or log into the Windows operating system with that user and try to connect to the database, it will also be rejected by the database, invalid username password. So why it has happened? Because in attempting to authenticate, in attempting to connect to the uh, database server does not identify, does not recognize this user as operating system authenticated user, because we have not informed the database server that the particular user should be authenticated at the operating system level. We just created the user at the operating system level and try to connect the database directly without informing the database that the particular user is operating system authenticated user. So Oracle is unaware of the OS authenticated DB user. So how to fix this problem? We have to use this Oracle parameter called OS authent prefix. So OS authent prefix in Oracle indicate which users are operating system authenticated users. So when you are creating a user at the operating system level and you want to give the operating system authentication for the user when the user attempting to connect with the database server, in order to fix this problem that we encountered earlier, we have to inform, or we want to explicitly declare that particular user will be operating system authenticated user. So how to fix this? In order to fix this, we have to create a user first with the same name as the user that we created in the operating system. But additionally, we add that very specific prefix, which we found in previous case, right? So here, the parameter OS authent prefix in Oracle, its value is here, right? OPS dollar. So the users with that prefix will be recognized as OS authenticated users by Oracle. Therefore, we have to include, right? So if you carefully look at this part, the user we created at the operating system was DB underscore user. However, when we are creating a database user for the user that we created at the operating system level, we add that prefix OPS dollar. So create user OPS dollar DB user and identified externally. So this will inform the Oracle server, okay, there is a user called DB user and the user will be externally authenticated. That is how Oracle understand that this particular user is externally authenticated and it is authenticated by the operating system. So this will create such a user. So the second statement is basically we allow the user to create sessions. So that is not related to authentication. Once authenticated, so we allow the user to create sessions. So the same thing in Windows, we have to create the particular user with the prefix in Windows order, right? Identified externally, and we grant create session to the user. And apart from that, if we are going with Windows operating system, then we have to configure this configuration parameter as well. So once we reconfigure this and we try to, we restart the server and try to connect, it will allow connecting, because now the Oracle server identifies, okay, when the DB user is attempting to connect with the database server, it will identify, okay, it comes with OPS dollar, so this should be a OS authenticated user, and it will check whether there is such a user in its records. Okay, it exists, so it will be allowed. So you see that there are many, there is a parameter here. Parameter here. You can set different values for these parameters in order to configure the user external identification, but with different modes. Like this is external identification with OS authentication. So that is one particular way of authentication externally. So in that case, we have to set this NTS. And if you set it all, so it will consider all authentication methods. So if you want to authenticate the user with external Kerberos protocol, so that will allow Kerberos authentication. And likewise, there are different ways that you can configure and get the external authentication. And this configuration parameter, SQL Net Authentication Services, is used to specify the authentication services that Oracle Net Service should use when authentication. So this is all about Oracle. And when it comes to a Microsoft SQL Server, initially you will be able to configure the database server with two authentication modes. The first is Windows authentication, and the second one is SQL Server and Windows authentication mode. So we call it mixed mode as well. And when you are installing the database server, it can be configured, and or else if you want, you can configure them later as well. So Windows authentication is the default authentication mode when installing SQL Server, as I remember. In order to support SQL authentication, you need to configure SQL Server to support mixed mode authentication. So when mixed mode is used, what happens is both Windows and SQL authentication can be used to connect to SQL Server. So basically that means if some of the users want to authenticate themselves through the operating system, and some of the users want to authenticate themselves separately by the database server itself. So if you want to configure the server in both modes, so you need to go to the second option. But if you want to connect only by your operating system uh, authentication credentials, then you have to use the first option. So it will not allow external authentications. So if we look at the Windows authentication, the first option, um, it's a secure way to connecting to SQL Server, and it uses uh, some tokens and some other security materials to authentication purposes in Windows environment. So Windows authentication basically means you only log into the Windows operating system and you don't need to provide your credentials to log into the database server. So it will automatically, or it will be verified with the operating system credentials. So in this process, uh, what uh, how it has been implemented is that is basically implemented on top of Kerberos authentication protocol. That is the default way of Windows authentication has been implemented. So when you log into the operating system, it will verify your identity. And once logged in and try to connect to database server, the operating system will pass tokens and some other materials. So it will be it will not require to authenticate yourself again to the database server. Therefore, it does not send passwords across the network and safeguard your passwords across the network. So this mod basically uses the logged in Windows identity to authenticate with the databases. Users do not need to provide separate username and password for the database. Instead, their Windows account is used to authenticate. So tokens and some other materials called SPN. SPN is service principal names. So tokens and service principal names will be exchanged when a user attempts to connect to SQL Server using this Windows authentication. A token is generated by the Windows authentication process, and it will contain information about the user identity. So it will be passed to the server, and also the service principal names. Name is used to locate and authenticate the SQL Server instance. And the second mode, SQL Server and Windows authentication in SQL Server, right? Here you can configure in this mix mode, and you can authenticate. Once you configure in this mix mode, you will be able to authenticate both ways, Windows authentication and SQL Server authentication. So the database itself will authenticate certain number of users, and Windows operating system authentication will be used for some other set of users. So that is the flexibility that this mode has. So when SQL Server is configured in mixed mode, you can set up some users to use Windows authentication and others to use SQL Server authentication based on the requirements and roles. Windows authentication accounts add Windows users or groups in SQL Server Management Studio and assign appropriate permissions to database or objects. So here, in order to configure Windows authentication, so what you can do is add Windows users or groups in SQL Server Management Studio and assign appropriate permission to databases or objects. So that is how you can do this for the users. And for mixed mode, sorry, not the mixed mode, for the SQL Server authentication, you can create SQL Server logins for different users using these create login statements. And then assign this account to specific databases and configure their roles. In SQL Server, there is a very specific way of handling these user accounts and the identities. So if you want to enable SQL Server authentication, which means the authentication happens at the database level, not at the operating system level, so you need to create user accounts in the database level, right? So create SQL Server logins for these users. You need to create SQL Server logins using create login statement. Assign these accounts to specific databases and configure their roles. Right? And so in SQL Server context, this login and user account are different things, right? So it's important to note that user login and user account are two different. There is a difference between them. So you first need to create login, right? And then for these logins, you can create different users for different databases. Right? So login is first created, and then for these logins, you create different users at the different databases. Right? For the same login, there can be multiple users, not in the same database, but in different databases. So database level authentication. So you see that first we create a login in database server, and then we specify which database that we are going to interact with a particular user. So we pick a database, and next we create a user. So we create app user, right? For the login that we created earlier, app user here, right? So we link this user with the user login. And then this statement is basically adding this user to a particular role, database role. So in database level authentication, which means the authentication happens at the database level, user credentials are verified against database. So database has its records about the identity and the user provides its credentials. So those will be compared and verified against the database. Typically, for applications and third-party software that connect to the database, typically uses this database authentication because applications and third-party software that want to connect to the database cannot log into a particular operating system and assign operating system user account, right? So that's why these software applications, software systems connect with the database need to be authenticated at the um, database level. For web applications where users create their own user accounts, so such accounts should be again connect with database through a database level user. Yes, this is what I meant here earlier. Login versus user. Those are two different things in MS SQL Server, right? So login is to authenticate a user. User account is to define an active scope of a user. So login is basically authentication purposes. For a user, there will be a login. It will determine or it will govern the authentication. However, the active scope of a user will depend on the role the user plays in a particular database, right? So in a single server, there can be multiple databases, right? Therefore, what SQL Server does in this case is for a single user should have a authentication uh, controller, authentication manager, which is basically the login. So the login is to authenticate a user. So now this will help to authenticate. So once the authentication happens, which means the identity is verified, then the user's scope or the active scope or maybe the role the particular user plays in different databases should be determined at the level of these databases, not at the level of login. So login is basically outside the databases. It's at the server level. And active scope of the user will be determined at each database level. So user probably in the database level while their logins are in the server level. Single login can be associated with multiple users in different DBs. So we basically create a single login at the server level, and then we create users U1, U2, U3 for these three different users, but associate with the same login, which means actually the same user, but their active scope or maybe the role is different in these three databases. So their active scope should be determined at the database level. Therefore, we create user accounts at the database level, not at the server level. So if we say that a login allows you to connect to the SQL Server services, and permissions inside the database are granted to the database users, but not to the logins. The logins will be assigned to server roles, and the database users will be assigned to roles within the database. So you see here again, we first create a login and the credentials, username and the password. So you can now log into the database server, but you are not going to work with any database. So then you go to the particular database, my database, and create a user with the same name, and it will be linked with the login we created earlier, app user. Now this app user is linked with the app user login. So once this particular user log into the database server, it can go for my database and work according to the role definitions here. So first you create a login, and then you specify a particular database, and then you create the user for login specified or login you created earlier. So some of the advantages of SQL Server authentication. So SQL Server authentication is basically your authentication happens at the database server level, not at the operating system level. So it allows SQL Server to support all the applications and applications provided by third parties that require SQL Server authentication. So non-Windows users, which means basically the software applications that connect with the database, right? So they can interact or connect with the database without problem. But if we specify you should authenticate with Windows first, then there will be a problem that users or the applications running on different operating systems will find it difficult to connect with SQL Server databases. Allows SQL Server to support environments with mixed operating systems where all users are not authenticated by Windows. So this is the second point. Third, allows user to connect from unknown, untrusted domains. So in that case, your authentication will be happening at the database level. So we do not trust any other environment. So if you are trying to connect with us, then you should be authenticated at our database level. Allows SQL Server to support web-based application where users create their own identity. So this will allow users to create their own identities with web application. So these users doesn't need Windows accounts. Next, allows software developers to distribute their applications by using a complex permission hierarchy based on known preset SQL Server login. And there are some disadvantages of SQL authentication, I mean database level authentication as well. A user is forced to log in twice and maintain two credentials, which means you first log into whatever the operating system you have. It can be either Unix or Windows. So you first log into that and then you connect with the database because it's in the SQL Server authentication mode. you need to be verified with the database server as well. And Windows operating system offers additional support in making these things secure, more secure, like password policies and other things. So those features are not available when you are trying to connect to the database with SQL Server authentication. And SQL Server authentication cannot be used Kerberos security protocol because it's directly authenticated at the database level. So Kerberos is an external mechanism which helps us to authenticate users. So we cannot use Kerberos kind of external authentication, strong authentication mechanisms that will be hosted external. So such services cannot be taken when we are going SQL Server authentication. So how we can create users with database authentication in Oracle. So the user will be authenticated at the database level. We need to create users in database, Oracle database. We have to specify the password. So this password will be stored in cryptographical protected form in Oracle. It's not just like stored as a plain text password entry. So it will be protected cryptographically. So what we can do is we just create a user at the database level with a password. So advantages of DB authentication, extra security layer at the DB level. So we can think it as an extra security layer as well. At the same time, if we want, we can look at it as a disadvantage as well because we need to authenticate twice. So it depends on again how you feel and how important this is. And this database authentication is independent of all the other authentication levels. So you can do authentication in different levels, disregarding the database authentication, and it's independent. So this will be easier with small number of users, but when the number of users grow, it will be difficult to manage. So this identified keyword when you are creating a new user, so it can be a password, or sometimes we can say that the user will be authenticated externally, like we configured our Oracle database for operating system authentication. We said clearly that this user will be authenticated externally, and in order to say that it is a operating system authentication, we added this prefix. This is how we do it for Unix, and this is how we deal with Windows. Yeah, this is how we define password-based authenticated users, and this is how we go with externally authenticated users. So we create users in different forms. Apart from these two, there are some other options in Oracle as well. You can state the user, or you can declare the authentication of this user as global, which means this option is used to conjunction with enterprise user security and enables global user authentication through a directory service. So global directory services can be used to authenticate users. So it's not um, password, it's not password based authentication at the database level. It's not the operating system uh, authentication by the user's computer. So this globally, we state that the user will be authenticated by the global authentication services such as global directory services. And also, you can have this authentication in a very specific, customized way or tailor-made for your application. So you can specify a PLSQL function to authenticate a user. So when this user with the username, this attempts to connect with this database, this user's authentication or the identity will be verified by this function. So this function should be written in this database as a PLSQL function. So this function will be called at the time of the user connect with the database. So this function determines whether the identity is verified or not. So some of the different ways in Oracle that authentication can be done. Database authentication. So users authenticate themselves directly to the Oracle database by providing their credentials. So these credentials such as username and password um, are stored in the databases records, user records, typically like in a data dictionary. Users are authenticated by comparing the credentials they provide during the connection with the credentials we have already stored in the database. So external authentication is, it allows users to authenticate to the Oracle database using credentials managed by external services, such as operating system or maybe any directory service. Likewise, when external authentication is enabled, Oracle passes authentication process to external service, like it's like a delegation. So users do not need to provide username and password directly to the Oracle. And instead of that, Oracle relies on external service to authenticate users. And global authentication is, it's like an extension to the external authentication. So it allows users to authenticate to maybe multiple Oracle databases within the same domain or network using a single set of credentials. So users can authenticate once to a central authentication service, maybe configured with the LDAP directory service, and then access multiple Oracle databases without providing credentials again. So it is basically global authentication is mainly providing or enhancing the convenience of users and centralizes user management. So it make things easier to enforce consistent security policies uh, across multiple databases. So proxy authentication is it allows users to connect to the data Oracle database on behalf of another user. So proxy, it behaves as a proxy. Proxy user must have necessary privileges to act as a proxy for the client. So we discussed this authentication using PKI SSL, which is certificate-based authentication. So we can configure our Oracle database authentication medium as certificate-based authentication, where we can authenticate clients and we can authenticate servers as well. So some of the key components that will or already that comes typically with Oracle. So it provides certification authority, so you can create your own security certificates, and trusted certificates are also come with Oracle, and Oracle has a wallet and wallet manager. So all these features will help you to keep your security certificates securely and enforce certain policies and authentication using security certificates. Also, you can configure the database server to authenticate with the help of Kerberos services. So Kerberos is basically facilitates client server authentication over insecure. So when we want to authenticate over untrusted or insecure not network, Kerberos will be a good solution. So what happens here is trusted third party involves in this case. So we want to interact with a particular service, let's say this. So in order to interact with this service, we need to, or this user need to have the trust relationship. Authentication should be happen first. But when the network is not so secure, this Kerberos protocol, what does do is it brings a third party to this scenario, and it's a trusted third party, trusted by the users and trusted by the service as well. So it will help us to authenticate these services when we have multiple services. So when we want to connect with these multiple services, right, we can interact and authenticate with these services with the help of this Kerberos service. So let's have a brief idea about Kerberos. Perhaps you may have already know this. So initially, this key distribution center, right, will be established, and there will be some uh, agreements, right? Uh, Trusted third, since this is a trusted third party, clients and services both trust this third party uh, entity. So key distribution center initially agree upon certain keys, right? So client and server, right? So this KC is initially agreed upon. So the client and the authentication server agreed upon a key, and then authentication server and ticket granting server, they both agree upon this yellow key, and ticket granting server and the service server, they both are agreed upon this KS, right? So these agreements have to be established priorly. Then when a client wants to interact with this service server, which means basically authentication must be made. So it first contact the authentication server, right? So this is the first step. And it contacts the authentication server. So what authentication server does is it sends this message, right? Right. So it sends a key encrypted by the key agreed between the client and authentication server. So this is a new key. And also it encrypts a message which includes client details, right? And information plus the key this authentication server sent to client, which is encrypted by this yellow key, and it is only shared between authentication server and ticket granting server. So this message cannot be opened by anyone else. So only these two can open. So once this message is received by the client, it has this key, right? This is available because this key is available here. It can decrypt it and get this key. So what it does is it encrypts its client information by the key it received and sent to the ticket granting server along with the message client received from the authentication server, which is encrypted by this yellow key. So this will be also a part of the message, right? So this is the same message that client sends to the ticket granting server. So ticket granting server can decrypt this message because it has this yellow key and it contains the client information, right? And the key, then with the help of this key, it can decrypt this and get the client information and verify, right? Verify the client. So the authentication can be made to the ticket granting server. So then what ticket granting server does is ticket granting server sends a key to the client again, which will be encrypted from the key client received from the authentication server, right? And also it sends a new message which is encrypted by the black key, which is only shared between ticket granting server and service server, right? These two. So this black key is shared only between them. So it includes a message which is encrypted by this black key that includes the key it sent to client plus the client information. So as the next step, client contacts service server, right? Service server is contacted with the message it received from the ticket granting server will be sent along with the client information encrypted with this blue key, right? So once the service server receives this message, it has this black key. So it will decrypt this and get the blue key and the client information, and it will decrypt this. It has the client information, so these two will be verified, right? So if all done, service server verifies client identity, which means authentication is established or done, right? So that is how Kerberos works. So in Kerberos, there should be a trusted third party, we call it key distribution center. So this involvement removes or eradicate the requirement of trusted network. So that is how, in some simple terms, how Kerberos works. Right. So we looked at different authentication modes in Oracle and SQL Server. Similarly, there are authentication modes in other relational databases such as Postgres, SQL, and MySQL. You can configure it, and it follows the most of the time it follows the standard SQL form. Next, we look at password management policies. This is not about authentication, but how we can enforce certain policy decisions in password management. So it is helping us to maintain secure passwords or protection of passwords. So organizations' policy can be enforced through these password policies in databases. So you may know that, or you may have experience in certain organizations, you need to follow certain policy decisions. You need to maintain a certain length of a password. You need to change your password periodically. You need to follow some other standard policies as well. So you can enforce this instead of keeping all these things in policies. You can enforce them. So the users must follow the standards when they are working with the database. So DBMSs facilitate implementing and enforcing these password management policies and standards. So in Oracle, there is a concept called profiles. So this profiles allows implementing these password management policies. So create profile statement helps to create profiles with policy decisions, policy restrictions. So this is an example, create profile, app user profile, and we enforce restrictions here. We can say that failed login attempts should be maximum 5, password lifetime 60. And likewise, there are so much of different other restrictions that we can list here, right? So after creating such a profile, you can assign it to user or role using alter user, alter role command. So how we are going to assign it to a user? We simply call alter user username. And we are saying that we are going to assign a profile, and which profile? This is the profile name. So another example, create profile, secure profile, limit, failed login attempts 5, alter profile, secure profile, limit, password, lock time 2. So once you create a profile, you can change it, right? adding more and more constraints. So you can check the profile as well. So select resource name limit from DBA profile. So DBA profile is a data dictionary view in Oracle. So you can call this. So you will see its restrictions or the constraints that we have enforced and their values. So you will see something like this. Composite limit session per. So these are the limits. What are the values that has been set? So at the time of you are creating a user, you can specify your profile as well. When you are creating a user, create user app user, identified by a password, and we assign a profile. We associate a profile. Some of the policy limits that you can enforce in Oracle. Inactive account time. So there is a restriction that we can enforce. So it locks the account of a database user who has not logged into the database instance in a specified number of days. So the default value is unlimited. Password lifetime sets the number of days the user can use his or her account current password, the maximum limit that it can go. Default usually 180. Failed login attempts. So it sets the maximum times a user try to log in and to fail before locking the account. Usually it might be 10. Password lock time, set the number of days an account will be locked after the specified number of consecutive failed login attempts. Password reuse max. So it's a restriction that sets the number of password changes required before the current password can be reused. Password reuse time, password verify function, likewise lots of restrictions that you can enforce. In SQL Server as well, there are similar statements that you can do, but a little bit different compared to Oracle, how we are going to implement it. So we have to create login statement to create a user login with policy restrictions. So at the time of you are creating a login for a user, you can specify these restrictions, right? So you may remember that when we create a login, we create it with the create login statement. And then at the latter part, we specify our restrictions, failed login attempts, password lifetime, things like that. Okay, and we saw that there are different authentication and authentication mechanisms and how those things are mainly used in Oracle and SQL Server mainly, but all the other database, relational database models follow the same standards, same mechanisms can be there. And if it is different, but it won't be much different from the these standard ways. Right, so if you have questions, we can discuss. Otherwise, we can end the session. Okay, it seems you don't have questions. Then I will end the session. Right, thank you very much for joining me the session and have a pleasant evening.
Thank you, sir. Thank you, sir.
Thank you, sir.